વેરી ગુડ આફ્ટરનૂન હેત.
ગુડ આફ્ટરનૂન સર.
કેવું છે બકા?
બસ સર.
બસ મજામાં?
હા સર, મજામાં કમ્પ્લીટ.
ઓકે ઓકે, ચલો સરસ. હેત, કેમ એટલી વાર લાગે છે બકા?
શું સર?
કેમ આટલી વાર લાગે છે બધાને આવતા?
સર ખબર નહીં તો આટલા ટાઈમે જ બધા જોઈન થઈ ગયા હોય.
मैसेज ड्रॉप करना क्लास में.
હે સર?
मैसेज ड्रॉप करना क्लास में.
હા સર, કર દો.
Very good afternoon, students.
Good afternoon, sir.
Was your lab too late?
Sorry, sir.
Was your lab left too late?
No, sir.
Then why did not you join this lecture early?
Sir, I joined it on 3:28.
Fine. I hope my screen is visible to all of you.
Yes, sir.
So, I would like to start the lecture as I have discussed with you previously also that this week I would be going with the prerequisite part which you have already studied in your first year of basic electronics. I am going to repeat it in a very fast mode because I understand that all of you are very much aware and very well aware about these terminologies. So it would be a quick review about the topic of analog circuit design. I hope all of you are comfortable with it. Uh, Motion enrollment number 19, is he available?
Yes, sir.
I would request you to remind me at the end of the lecture to just brief about the modifications in timetable.
Okay, sir.
Okay. So hereby I start with the prerequisite of analog circuit design. As you are very well aware about the subject of analog circuit design, it basically starts with the transistor part. So I am briefing you about the transistors in a very short span. The BJT amplifier is broadly classified in three categories as we have discussed in our previous lecture also. It is known as CB, CE and CC configuration. I hope all of you are well aware about these terminologies, that these are the three terminologies in which the BJT amplifier is very well equipped with. The most common configuration is a CE configuration because it is the application of this CE configuration is amplification or amplifier rather. As you can see the circuit of an amplifier where we are having a RC coupled CE amplifier. The transistor, which is this particular transistor? Can anyone just reply, PNP or NPN? Hello students, I hope you have to be very much fast in interaction. Do not sit idle in the class, whether it's PNP or whether it's NPN.
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 It's an NPN transistor with three capacitors C1, C2 and CE. Now, as you can see, I have drawn two things. One is the input and one is the output part. Now, if we talk about the input part or the output part, there is a very wide difference between both of them. First of all, I would like to start with the capacitors, that is C1 and C2 capacitors. These are known as C capacitor. Basically, it is CC. CC over here means coupling capacitors. RL, that is the load resistance which passes through the coupling capacitor. CC, that is through the collector side. So RL is across C2 basically. RL is across C2. We are having three resistors R1, R2 and RE. RE is basic, RE, R1 and R2 are basically known as biasing resistors. Biasing resistors. And as we already know that whenever we talk about CE amplifier, the CE amplifier basically operates the transistor in active region. The CE amplifier operates the transistor in active region, as you can see in the circuit. This is the topic that you have already studied in 3110016. There are various types of biasing. Basically, in this particular topic, we are focusing on voltage divider biasing. Voltage divider biasing basically means that there are two resistors R1 and R2 parallel to each other before the base connection, as you have seen in the circuit. And the other kind of biasing is known as self-biased circuit. In the given circuit, the coupling, the collector resistor, that is RC, controls the collector current IC, and the features of the same are this. All of you are requested to kindly note down the features so that I can proceed further. Once you note it down, please let me know yes or no by unmuting yourself.
Done, sir.
Okay. So I hope
Done,
all
sir.
of you have done.
Done,
So
sir.
I'm proceeding further with the features of our RC coupled CE amplifier. Can anyone explain me the features which I have written? The significance. What is AV? Rishi, AV. Hello, Rishi, are you there? Hello,
Yes,
Rishi.
sir. Yes, sir.
Rishi, what is AV? Hello, Rishi.
Don't know, sir.
Rishi, you do not know what is AV. Very good. Uh, Ritu. Hello, Ritu. I hope I am audible. Ritu.
Yes, sir.
Ritu, what is AV, beta?
Sir, voltage gain.
Yes, beta, very good. So voltage gain is very high. So Ritu, what is AI then?
Sir, current gain.
Yes. So AV and AI are very high in case of RC coupled CE amplifiers. That is, voltage gain and current gain are very high. Along with it, the input resistance or input impedance is high in case of RC coupled CE amplifier, and the output resistance is quite low. Output resistance is quite low. As you can see in the circuit also, the input and output is with a phase difference, of 180 degree, of 180 degrees. Fine. So that is how we connect it, and these are the basic features of a RC coupled CE amplifier. Now we move on further with the amplification purposes, that is CC amplifier. CC amplifier, or commonly known as emitter follower circuit. Please draw the circuit. Once you draw, please respond. Common collector amplifier, or commonly known as emitter follower circuit.
Done, sir.
Okay.
Done, sir.
Okay. Thank you. Just wait for 1 more minute till all others complete. Then we will proceed. Rest of you, have you completed? Can I proceed?
Yes, sir.
Okay. Now, the features or the emitter follower circuit basically says that the output over here follows the input. That is why the name is emitter follower. The basic feature of a emitter follower circuit is the input is at base. I repeat, input is at base, output is at emitter side, not at collector side. Output is at emitter side. Secondly, the voltage gain. The voltage gain is approximately equal to 1. The voltage gain is approximately equal to 1. The current gain is equal to 1 plus beta. What is beta? That we already know because we have already read this topic. Zi, that is the total input impedance, or the input impedance is increasing and output impedance is quite low. The most important part is there is no phase reversal. That is, input and output both are in the same phase, which was not the case in case of a CE amplifier. So this is the basic difference between CC and CE amplifiers, that there is a phase reversal case which is not there in CC. Now, basically, Ajusudi, what we have done is we have done various circuits and we have tried to understand that how these circuits react or amplify the given low voltage signal or a small level signal. But now, for going for AC analysis, we need to convert the given particular circuit into AC equivalent model. I repeat, we want to convert the given circuit to a AC equivalent model that we have already studied in our first year course. That we have already studied in our first year course. So I am going to repeat it in a very brief note. These are the rules. These are the rules for AC equivalent model. There are basically 5 rules. There are basically 5 rules. The first rule is whichever circuit is being given to us, we would replace, I repeat, we would replace all the DC sources by short circuit. We would replace all the DC circuits by short circuit. Rule number two says that we would replace the capacitors present in the circuit by short circuit. By short circuit again. Why? Because the reactance of these capacitors is very small at frequency operations. So whenever we are working in terms of frequency, either small level or high level frequencies, during those signals, the C would not react. So C can easily be replaced by short circuit. Because of the reactance of these capacitors is very small at higher frequencies, so the capacitors can be removed when we are going for AC analysis. Hello students, are you all there? Are you all listening?
Yes, sir.
Yes, sir.
Okay. So rule number 3 is CE, that is the bypass capacitor, is short circuited. So RE is bypassed, that is, it is directly connected to ground. Plus VCC is already connected to ground. Therefore, the collector resistor RC is between C and ground, and hence R1 would be parallel to R2. R1 would be parallel to R2. I request all of you to please write down the 5 rules so that I will give you the circuit and then you need to replace it. Please write down the rules. Once you write down, please let me know.
Done, sir.
Okay.
Done, sir.
Okay.
Done, sir.
Okay. So I hope the circuit is visible to you clearly. According to our talks, according to our talks, our first work is to our first work is to replace all the DC sources available by short circuit. Our first work is to replace all the DC sources available by short circuit. And hence, what we are going to do is this thing is a AC source, so this thing would not be removed. But the capacitors like C1, C2, and CE, all the three capacitors would be removed. If we are removing all the three capacitors from our given circuit, then what is remaining? Then what is remaining is only the circuits. And it was being told that CE or whatever capacitors we are removing, that we need to short circuit. So I hope you are able to understand that why we are short or what we are short circuiting over here. Right? Getting it?
Yes, sir.
Yes, sir.
Rest all things are grounded. Rest all things are grounded, including this ground. Now this is VCC grounded. This is we are grounding VCC. That is RC is between collector and ground. This is my RC. This is my RC. So it is between ground and collector. It is between ground and collector. Now, according to rule number 5, R1 is parallel to R2. R1 is parallel to R2. Hence, I will be getting something like this and finally this thing. Guys, if you are having any doubts in it, please let me know. How we have modified the circuit, that you must understand. Any queries? Hello students.
No, sir, no queries.
No, sir, no queries.
Okay, good. '38 number, have you drawn the last circuit? Rahul Rajput,
Yes, sir.
have you drawn the last circuit?
Sir, that sir, which one?
સર અત્યારે જે સર્કિટ તમને સ્ક્રીન ઉપર દેખાય છે એની વાત કરીએ છીએ.
સર રૂલ્સ પછી તમે ઉપરનું સર્કિટ બાકી છે સર.
તો બકા પ્લીઝ બોલો બાકી હોય તો, એટલે આપણા પછી નેક્સ્ટમાં ના જઈએ.
સર રૂલ્સ લખી દીધા છે.
ઓકે. અંતરા ખ્યાલ આવી ગયો? 41 નંબર. Hello 41, are you there in the class or you have just started the mobile and left somewhere at some other place? 41. Hello 41. Very good. 43 ऋषि, बेटा समझ में आया?
Yes, sir.
ओके. 52.
Yes, sir.
Okay. So I am proceeding further, and based on this, I would be using my various AC analysis models. So there are broadly classified in three categories, that are these. The first category is a small signal RE model. The second one is the hybrid model, which is basically H parameter model. And the third one, that is a pi model. The third one is a pi model. Now, before I move further, I would like you to answer few of my questions. "46 number,
Yes, sir.
बेटा एच पैरामीटर की दोनों इक्वेशन चाहिए आपको, यदि याद हो या कहीं लिखी हुई हो तो बता सकते हो?
Yes, sir. Sir, 2 minutes.
हाँ प्लीज. "57 number,
Yes, sir.
બેટા ચારે ચાર એચ પેરામીટર ના પેરામીટર્સ કયા કયા છે? ફોર એક્ઝામ્પલ લાઈક H11 અને બીજા કયા કયા છે?
H12, H21, H22.
હા કરેક્ટ. હવે આપણે તમને ખ્યાલ હોય તો નેટવર્ક થિયોરીમાં પણ અને બેઝિક ઇલેક્ટ્રોનિક્સમાં પણ આપણે આ ચારે ચાર પેરામીટરના CE, CB અને CC કન્ફિગરેશન લખ્યા હતા. I think you are ધાર્મિક, right? 57.
Yes, sir. Yes, sir.
હા બેટા. તો તમને ખ્યાલ છે આપણે લખ્યા હતા?
Sir, યાદ નથી.
ઓકે. 46 નંબર ઇક્વેશન મળ્યું બેટા? હેલો 46.
Yes, sir.
इक्वेशन मिल गया?
हाँ सर H11
अबे क्या करूँ अभी
अ,
मेरा मतलब
V1
चल रहा है
अपॉन I1।
मैथमेटिक्स। अभी तो बॉम्बे थी मैं 10 दिनों से। हाँ हाँ, अभी 2 दिन पहले ही आई।
46. Hello, 46. 47.
યસ સર
બેટા H પેરામીટરની બે ઇક્વેશન ખ્યાલ છે?
જસ્ટ અ મિનિટ સર
Please note down the equations. Then we can discuss about these parameters. Forty-seven. Equations दिखाए छे?
યસ સર
Equations दिख रही हैं? Okay. ऋषि आ 4 इक्वेशन प्रमाणे कई ख्याल आयो?
Yes, sir.
What is H11? What is H12? H21, H22 known as? नाम लखाया था आपने. In previous semester and previous to previous semester, in both the semesters. Moshin,
यस सर
बेटा नाम याद आया?
ना सर નથી આવતા યાર
सरस. पाटिल, हिमांशु, if you have written the equations, then we can discuss on it. Please let me know once you write it. So we are having H11 as VI upon II. So basically, આપણે equations we basically write I. So over here, V2 is nothing but V naught. V2 is nothing but V naught. And in similar way, Vi is nothing but V1. Vi is nothing but V1. So V1 is nothing but the input voltage and V2 is the output voltage. In similar fashion, II is the input current, that is I1, and I naught is the output current, that is I2. I hope you are able to understand this particular feature of the two equations. Please respond yes or no.
Yes, sir.
Yes, sir.
Yes,
So
sir.
based on these two
Yes,
equations, we are, thank you. Based on these two equations, we are now finalizing the four unknown parameters, that is H11, H12, H21 and H22. I start with H11. H11 is known as Vi upon II. H11 is known as Vi upon II. This is nothing but at V2 is equal to 0 or V naught is equal to 0. We can say that. Similarly, H21 is at I naught upon II when V naught is equal to 0. I hope you remember how do we calculate all these four unknown parameters.
Yes, sir.
So VI upon II, that is input voltage upon input current. Hence it can be termed as input impedance. ऋषि ख्याल आवे छे?
Yes, sir.
Rishi, kindly keep yourself unmuted and hate you also, if possible.
Yes, sir.
Yes, sir.
So Rishi and hate, this is H11, which is nothing but input impedance. And we are trying
Yes,
to
sir.
focus that this input impedance, that is VI upon II, is nothing but H11 when V naught is equal to 0. So if my output voltage is 0, I can say that my circuit is short circuited. My circuit is short
Yes, sir.
circuited, and hence H11 is known as short circuit input impedance. H11 is known as short circuit input impedance, and it is denoted by HI. It is denoted by HI. The next one, that is the next one, that is H12. H12 is input voltage upon output voltage. Input voltage upon output voltage. So basically, whenever we calculate voltage gain, we calculate output upon input. But here it is input upon output, so definitely it is a reverse. Hence, this
Yes,
is
yes.
reverse transfer voltage. Hence, it is known as reverse transfer voltage. And if the input current is zero, that means there is no input. That means our input is open circuited. Hence, H12 is known as open circuit reverse transfer voltage. H12 is known as open circuit
Open circuit
reverse
reverse
transfer.
transfer.
Yes, and it is denoted by HR. And it is denoted by H. The third one is the third. अरे यार. The third one is H21. This H21 is nothing but output current upon input current. Output current upon input current. And this output current upon input current is being measured when V naught is equal to 0. When V naught, that is my output voltage, V2 is equal to 0. So this is nothing but basically the current transfer ratio in forward side. Hence, it is short circuited forward current transfer ratio. Short circuited forward current transfer ratio. Similarly, we are focusing H22, which is nothing but open circuit output admittance parameter, which is denoted by H naught, which is denoted by H naught. So we are having four parameters, that is HI, HR, HF, and HO. Now, please all of you listen. I repeat, please all of you listen very, very carefully. If we are having three basic configurations, that is CE, CB, and CC. If we talk about any one of the configurations, for example, I'm talking about CE. For example, I'm talking about CE configuration. સોરી મેં તમને ડિસ્ટર્બ કર્યા બધાને. તમારા ઘરે ખરેખર બહુ જોરદાર કામ ચાલે છે બધાના ઘરે. હું એકલો નવરો છું. વાંધો નહીં. So I'm talking about CE configuration. In case of CE configuration, we can say that emitter is common. That means emitter is grounded. So whenever we calculate the four hybrid parameters for any one particular configuration, we need to take out the formulas based on these four parameters, that is HI, HR, HF, and HO. For example, I am talking about CE configuration. In case of CE configuration, what is my input? Hello. In case of CE configuration, what is my input?
Base.
Base is my input. Emitter is grounded and collector is my output, right? So by VI
Yes.
would be what? What would be my VI? Students, hello. What would be my VI?
In,
Hello. What is my input voltage? Hello.
VBE.
Yes, VBE. And what would be my II? That is my input current. IB.
IB. IB.
Right? So in case of CE configuration, I can say that my VI is equal to VBE and my II is nothing but IB. So what is V naught over there? Output voltage to thase VCE. VCE, yes or no?
Yes, sir.
Yes, sir.
Any student in the class who is not able to understand this particular point? અહીંયાથી આપણો કોર્સ ચાલુ થાય છે એટલે જ પૂછું છું. કોઈને કશું ડાઉટ છે આમાં?
No, sir.
Students, please reply yes or no by unmuting yourself. If you sit silent, that means you are not aware and
No,
you are
sir.
not.
No, sir.
No, sir.
So V naught over here means output voltage, and output voltage in case of CE configuration is termed as VCE. So what is my input current? Input current is IB. So II would be replaced by IB, V naught would be replaced by VCE, VI would be replaced by VBE, I naught would be replaced by
I see.
IC. Very good. So please calculate all the four parameters. Please write down all the four equations for all the four parameters of H for CE configuration so that we can proceed further. My dear students, please write down the formulas.
Sir, लिख दी.
Okay. आई होप आपको स्क्रीन पे सब फॉर्मूलाज दिख रहे होंगे जो सीबी सीई और सीसी कॉन्फ़िगरेशंस में होने चाहिए. अकॉर्डिंगली आप मुझे एक पूरा टेबल बना के बताइए जिसमें आपने सब फॉर्मूलाज लिखे हैं फॉर ऑल द कॉन्फ़िगरेशंस ऑफ सीबी सीई एंड सीसी. प्लीज डू द नीडफुल. Once you are through, please let me know. Yes, students, what is the status? Please let me know. Hello, students.
Yes, sir.
હેત કમ્પ્લીટ થઈ ગયો બધું?
ના સર, સી બાકી છે સર.
Enrollment number 50, 50.
Sir, doing.
Okay. Keith Makadia, enrollment number 16. Ruturaj. Anurag. Ritu.
Yes, sir. Doing it, sir.
Yes, sir.
Once you complete, please let me know.
Okay, sir.
Sir, done.
Okay, Heath, thank you.
Yes,
Just
sir.
wait for others to complete. Yes, just wait for the other students to complete. Okay, Heath, please wait.
Okay, sir.
Done, sir.
Okay, Rishi.
Done, sir.
Okay, thank you. Enrollment number 50, 50. Okay, dear students, I hope that in my next lecture you would be able to share with me your screen to show me the basic configuration of H parameters for all the three configurations, that is CB, CE and CC. I hope I am audible and clear.
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
okay. Now, as I told Moshin, just to remind me, I would like to share with you the change in your timetable. And do not worry, I will be sharing this timetable in your WhatsApp group. The thing is that uh, this particular lecture is now no more because it was an extra lecture of signals and systems. Because of some unavoidable circumstances, this lecture has been removed. And today you found a error that At 1:30 you were having a lecture of Rohit Parmar sir. Now this lecture is at 3:30 and my lecture is going upside, that is at 1:30. So there is no lecture of Rohit Parmar sir over here in Friday. Rohit Parmar sir would be having three lectures: Monday 2:30, Tuesday 3:30 and Thursday 3:30. I am having four lectures: Tuesday 11:30, Thursday 1:30, Friday 1:30 and Saturday 11:30. I hope it's clear.
Yes, sir.
Yes, sir.
Any doubts in any of the cases?
No, sir.
Thank you. That's all from my side. Just wait for a minute till I take the attendance. Then you may leave. Thank you, students. That's all for today's lecture. Now you may leave. In case of any doubts or queries, please feel free to ask.
Thank you, sir.
Thank you, sir.
Thank you, sir.